Oh no, it's already recording. Oh yeah, it's already recording. Let's go. All right, cotan time. All right, y'all love tangent. Speaking of tans, have a good spring break, everybody. It's coming up. Go get a tan. And we're gonna get what? 3 inches of snow on 3 to 5 inches of snow on Friday. All right. So we are looking at cotangent. Now, cotangent is a lot like tangent, but we got, like, have we seen this equation before? Yes. Some things I need to keep in mind, though. Cotangent is 1 over tangent, right? Keep that in mind. It's going to come up a lot. It's 1 over tangent. So don't draw anything I'm going to draw up. I want you to think about this. That's tangent, right? So at 0, what's tangent equal? 0. So you have 1 over 0, which would make that a asymptote. Where here I had 1 over 0, and when I flip that, I get 0 over 1. So for cotangent, wherever tangent was a 0, I get an asymptote, and wherever tangent was an asymptote, I get a 0. So keep that in mind. If you know tangent, you know cotangent. So for cotangent, I have an asymptote here, right? And I'd have an asymptote here, and I'd have it every, what's my period of tan? Pi. So what's my period of cotan? Pi. So every pi I'm going to have an asymptote. But now my zeros are where my asymptotes were. So I have one at pi over 2. You know, split the difference, right? I did that right. Now the other thing is we're switching our x and y, right? So that's kind of like almost doing an inverse. So instead of going up, cotangent goes down. It goes the opposite way. Do you know what's kind of neato about this one? If I did a negative tangent and shifted it pi over 2, it would be cotan. You know what I mean? Like, right? They're the same thing. Flip it, shift it. This is going to be an identity that we're going to see later. But again, even if you don't memorize it, I want you to think about what the graphs look like. Tangent and cotangent are very similar, right? Just flipped and shifted. So like I said before, if you're good with tangent, cotangent, you're going to graph it the exact same way you did before. But instead of starting with a 0, you start with a asymptote. Sound okay? Doesn't that feel a little bit better than like 310? We'll end on a good note. Ooh, can I leave that graph up here, kind of? Whatever. I'll figure it out. Let's answer these questions while looking at the graph I have. So what's my domain on this? I'm restricted on my domain, just like tangent. By my asymptotes restrict me, right? Where's my first asymptote? 0. So x can't equal 0 plus pi k, right? Where, of course, k is an integer. I almost became Arnold Schwarzenegger for a second. All right. Do I have to write this 0 plus, though? No, I'm not going to, right? Could you write the 0 plus? Yeah, if you're a nerd. Well, I am one. All right, so what about range? Negative infinity to positive infinity, just like tangent, right? What's my x-intercepts? What's my first x-intercept? It was pi over 2. And then I'm going to add to it pi k, where k exists in the integers. Could I have picked any of my intercepts? Yeah. Usually I just do the first positive one. Nope, because k can be negative according to that. Because integers means you have -2, -5. It's just all your whole numbers, positive and negative. So you don't need a negative. All right, what about my y-intercept? Will I ever cross that y-axis? No dice. No dice. Don't write that in your test. I went, yeah, that'd be fine. Does not exist is also a good answer because it does not exist. Now, they're just looking for a no. Technically, I think they would take no dice. Do it. No dice. You got to write like that, though, right? No dice. Like Charles Bronson in Hard to Kill. It's from a movie that you guys would. Yeah, Charles Bronson. All right. Right. No dice, all caps, exclamations, question mark. Oh, is it odd? If I rotate it 180 degrees, if I take that graph I had, take your paper, flip upside down. Is it the same graph? Yes. So is it odd? Yes. Remember, odd is 180 rotate. Even as it flips on itself. Odd, you rotate at 180. So if you can turn your paper over and the graph looks exactly the same, it's pretty odd. So that's symmetry about the origin, right? Do you know about Charles Darwin's father, Erasmus Darwin? He wrote the book on the origin of symmetry. That's not true. That's not true. But he did. His grandfather was Erasmus. All right. Yeah. Origin on Species was the book he wrote. All right. Now, do I have asymptotes? Remember back from Unit 1, what's true about my domains and asymptotes? They have the same restriction, right? If X can't be that, what is my asymptote? X is that, right? Does that ring a bell? So I know it sounds goofy, but we have been reviewing Unit 1 a lot, this one, with our graph stuff, going back and forth. Look at us go. This is too easy. Just one more. Yep. I could have probably done this on the video, but life was hitting me hard. I actually only had 10 minutes during my prep to do it, so I was like speed demoning. All right, let's graph this beast. All right, graph y equals cotangent of 2x. All right, so remember, does our amplitude dual? Our amplitude gave us that, no, it's not our amplitude, but A gave us how far we went up from our zeros. Do you guys remember that? So like, normally, that's tan, but cotan works the same way. Like if that was 0, 0, then this would tell us to go up A, whatever that, or not A, we'd go up whatever A, right? How far up and down we went from it. All right. Does this have a phase shift in it? No. Does it have a vertical shift? Up and down? No. What's my period of it going to be? Yeah, it's pi over 2. So because I don't have a shift, where's my first asymptote? I'm going to start with an asymptote. Where's it going to be? At 0, right? I'm not moving it. Then where's my next asymptote going to be? Pi over 2 because I go over pi over 2. And the next one's going to be Jiminy Crickets. This is too much. I'll be honest, graphing, I found on the whiteboard, it's way easier than graphing using like a Mobi and stuff. It's way easier. Any questions how I got these asymptotes? Start at 0, add your period. Now, where's my zeros always going to be for cotangent, tangent? They're right in the middle, right? So my zeros are right in the middle. Now, there's no negatives on it, so it's going to go down, right? Cotangent goes down. Jiminy Crickets. Why are they doing this to me, man? Yeah, sorry, I also did one wrong on there. I completely forgot to change the period. It should have been a lot wider. And to be honest with you guys, I had 8 hours of sleep over 4 nights since Saturday because I've had sick kids in the middle of the night. Last night I got 6 hours of sleep. So I'm feeling really weird today. This feels really weird. Get a nanny. You're hired. All right. Teachers are well known for their amount of money to hire nannies. Now, remember, if I had an A in front, what is my number in front? This is just a reminder, 1, right? So technically that'd be up 1 and down 1, right? From halfway, we cut in half again. Do you guys kind of remember doing that? I'm just bringing it up because it's something we haven't seen in a while. Whether I say a while or not is up to me. All right, let's take a look at this beast. Here's what I'm going to do with this to make my life a little bit easier. What's this plus 1 going to do to all my zeros? Move them up 1. So I'm going to put a dotted line here. I'm going to treat that like my zeros, right? Does that kind of make sense? It'll make my life easier to have a guide point to go off of. What's this negative going to do? Yeah, it's going to look like what? It's going to look like tangent now. Yeah. What's my period? Pi over 2, right? So it's just 2. Quick thing, if they give you something to graph and you notice there's not pi's on it, they probably go away when you find the period. You know what I mean? Like, they don't try to be that tricky. All right. So with cotangent, what's the first thing I like to start with? That is tangent, I start with a 0 usually, right? You guys remember that? I'd go at 0. So cotangent, I'm going to start with a asymptote. What color should I use for asymptotes this time? Let's do red. So I'm going to start with an asymptote. Where's my next one going to be? At positive 2, 4. With cotangent, tangent, we're pretty much done. Once you have your asymptotes in and like you're kind of like your midline, you did the hard stuff. Because then now instead of putting it at 0, I'm going to put those on my dotted line, right? Cut them in half and put a dot. I don't want to use this marker. It's not going to show up well. Right. Now again, reminder, halfway in between each of these, I would go up 1 and down 1 based on my A, right? If I had a 3 in front, if I had a vertical stretch of 3, I would go down 3, up 3 from it. Okay, just a reminder. That doesn't matter a lot with cotangent because you're looking for end behavior and asymptotes and zeros. Like that's what matters. But it could matter because I know a 0 now. You know what I mean? Like that 0 is going to be at negative 3.50. All right. And again, why am I going up on this one? Yep. Doop. Whoa. I got a little linear there. All right, I do have to pause it. If I go over homework, I can't show that because that's